Now in this question, two trains are there which are running in the opposite direction. So obviously this is the part of and the question of relative speed, in which both the trains are running in the opposite direction. And also one more information is given, which is a person who is standing on the platform, a man standing on the platform will get crossed by train 1 in 27 seconds and train 2 by 17 seconds. Okay, and they cross each other in 23 seconds. This is how the data is given. So let's write down this data, given data, in some tabular form. So what we will do, we will consider train 1 here, train 1 here, it will be train 2, and here it will be crossing the trains with each other. Okay, these will be three different scenarios. In all three scenarios, 1 2 3, there will be these terminology: speed, there will be distance, and there will be time. Okay, so what we will do, speed and distance is obviously not given, only time is given everywhere. So what we will do, we will consider speed of train 1 as s1, speed of train 2 as s2. So when they are crossing each other, relative speed will be s1 plus s2. This is very simple. Distance is also not given, so let's consider variable as d1. d1 will be distance of train 1 when it is crossing the person in 27 seconds. d2 will be distance of the second train when it is crossing the person in 17 seconds. So basically this d1 and d2 is nothing but length of train 1 and length of train 2. And when they are crossing each other in 23 seconds, the distance covered will be length of train 1 plus length of train 2, which is d1 plus d2. So you can consider this as L1 L2 or d1 d2, that is no problem. And what about time? Train 1 is crossing in 27 seconds, the person. Second train is crossing the same person in 17 seconds, and then when they cross each other, it is taking 23 seconds, so it will be here. Now from this data we can have formula for this, we can have formula for this, and we can also have formula for third situation. But before that, what is the formula? Speed is equals to distance upon time. Now here we have to find out what we are concerned about, the ratio of their speeds. So we have to consider speeds, and somehow we have to neglect distance and time. Somehow we have to neglect it. Time is already given in numbers, so easily we can neglect this variable. But somehow we have to neglect this d also, length of the train or distance covered. So how we can do it? So simply we can convert this formula, which is like this: distance is equals to speed into time. Distance is equals to speed into time. So here it will be d1 is equals to 27 s1, right? Speed into distance, speed into time, distance is equals to, and here d2 will be equals to 17 s2. And in this case, third case, d1 plus d2 will be equals to 23 s1 plus s2. So this 23 will be multiplied to both s1 and s2. Now what we will do next, let's add these two, this and this we will add. So that will be 27 s1 plus 17 s2 is equals to what? d1 and d2 we already have, so let's equate with it. So it is 23 bracket s1 plus s2. Now by using this equation we can find out the ratios. How we can find it out? Let's open this bracket first. 23 s1 plus 23 s2, this will be the multiplication, and here already we have 27 s1 plus 17 s2. Now we will rearrange the terms so that 27 s1 minus this 23 s1 will be on one side. On the other side it will be 23 s2 minus this 17 s2, right? So what we will remain with? we will be remain with 27s1 minus 23s1, that will be 4s1 is equals to, and 23 minus 17 will be 6s2. So this gives s1 upon s2, which is the ratio of their speeds. S1 upon S2 will be 6 upon 4, and after simplifying it will be 3 upon 2. So option B, 3:2 is correct.